It's so cool.
Okay, we're going to model polynomials with algebra tiles.
Oh, I scraped my arm so bad.
And the idea
Yeah.
the idea of polynomials is actually connected to things you've done in real life that make a lot of sense. It's just, can you make that connection from real life to algebra? That's sometimes hard. So what I have here in my left hand is 3 pencils. What I have in my right hand is 2 pencils. If I put them together, I have 5 pencils. Okay? No problems there. Okay. What I now have in my left hand is 2 calculators and a pencil. And in my right hand, I have 1 calculator and 1 pencil. If I put them together, what do I have?
3 calculators.
2 pencils.
3 calculators and 2 pencils. It's so easy to see that. Okay? Nobody would say when I put these together that I now have 5 calculators. And nobody would say I now have 5 pencils. And yet you will make that mistake in algebra. Because in algebra, what we're doing is instead of saying calculators and pencil, we're saying X's and Y's. Or maybe we're saying, even more confusing, is X's and X squareds. So I'm going to rename this. This is no longer a calculator. This is now called an X squared. This is no longer a pencil. This is now called an X. In my left hand, I have 2 X squareds and 1 X. Can you see that?
Yep.
Yeah.
In my right hand, I have 1 X squared and 1 X. Can you see that? What do I have in total? I have 3 X squareds and 2 X's. Because you can do it so easily with calculators and pencils. The idea is the same in algebra. So one of the ways they try to help us with that in algebra is introducing shapes for the letters. And they introduce shapes based on area. So what they do is they say, if I want to say X squared, I'm going to call X squareds big squares. I'm going to take them out here. Got some ready. So now, these are X squareds. And for those of you that really love math, the reason they chose this shape is they said, if we make a shape that's X on this side and X on this side, the area of this shape is X squared. So algebra tiles are based on area. But anyways, what you're going to remember is big squares are X squareds. With my algebra tiles, I don't have clear ones. When we draw a negative one, we draw it clear. In the ones that I have here, my negative ones are red. Okay, I actually almost want to go just color code things the same. I'm going to color this one in green. There we go. I feel like I did a pretty good job coloring. Maybe I should quit teaching math and become an art teacher. So in our Algetiels, the red ones are negatives, the blue ones are positives. Okay? And if you have a negative and a positive, they cancel each other out, they would go away. So our X squares are big squares. Our X's are going to be straight little rectangles. These little rectangles match up to the exact same height as the X squared one, but they're only 1 unit on the bottom. So for those of you that love math, based on area, this side's length, we don't know, we say it's X, this side's length is 1. It has an area of length times width, X times 1, and area of X. And again, when we're drawing them, you'll shade them in to represent positive ones. You will keep them empty to represent negative ones. In the Algetiles that I have right here, the negative ones are red. The positive ones are blue. So now I'm going to put some in my left hand, some in my right hand. Can you see that in my left hand I have two big squares and one little rectangle? And in my right hand I have two little rectangles and one big square. If I put them in together, what do I have in total? I have 3x squareds and 3x's. So algebra is the idea of counting things just like you've counted before. I'm like, ooh, I can take these papers, 3 of them here, 2 of them here, right? What do I have? I have 5 papers and 1 x squared. So you guys have been doing algebra your whole lives, okay? What makes it difficult is partially we add negative numbers. Now, adding negative numbers in real life look like this. I have 5 papers. Mr. Shirk takes, how many did he take?
2.
2. How many am I left with?
3.
3. That's super easy subtracting, okay? But sometimes in algebra and in real life, we end up going into the negatives, right? I checked the temperature yesterday. It was 2 degrees. At night, it went down 7 degrees. What was the temperature at night?
-5.
-5. Right? There we went into the negatives. It's really hard to show negative papers. Our brains, certain things you can't negative them.
I have $50 in my account, but I just swiped a $75 product. What am I at in my account? Negative.
-25 plus another -$5 fee that they charge you for going into the negatives. Uh-oh. Has that ever happened to you? Do you have has the bank ever said you took out too much money and we have to charge you a fee?
They couldn't do it because they don't have overdraft.
At that age, you're not allowed to do that. Yeah, I can do that. And they actually like it when I do that because they like to charge the fee,
That's right.
right? They're happy when I make that mistake. And then these tiny little ones, I don't know if you can see them. These tiny little squares, those are ones. Positive ones will shade in, negative ones will leave open. And just like when I held up the calculators and the pencils, you were able to do the math super easily, okay? But in algebra, with the negatives involved, I guess, here's a good way to see the negatives, okay? Maybe I'll do it this way. I handed out 4 calculators to students. And when I got them back, I got this one, this one, this one, and this case, which is missing the calculator. So we can kind of think of this case as a -1. Or maybe, even better here. There we go. Right? These are full calculators. Here's a calculator and here's a case. That's not 2, right? It has to sort of get combined and counteract each other. So what we're going to be doing in math is sometimes we're going to say that every time you have a positive one and a negative one, does it make sense that that would cancel out?
Mhm.
If you get $1 and have to spend $1,
You have no money.
you have no money left. Positives and negatives cancel out. So when we're drawing our algebra tiles, sometimes we're just going to say what we have, and sometimes things are going to cancel out. So in these first examples, we want to write what we have. The shaded ones are positive. I'm going to make these ones green. Oh, look at that coloring skill. How are you? Yeah, post this video and then I'm probably gonna Instagram's gonna get lit up with job opportunities.
You can email it a lot of money. Of course.
Yeah.
Yeah.
I don't know, almost nothing out loud.
Okay. What we're going to say for this one is, what do we have? Okay. If we were using English words, you'd probably say we have 2 green rectangles and 4 white squares. That would make sense. But what are the green rectangles? The green rectangles are x's. So we have 2 x's. What are the white squares? Negative ones. So how many negative ones do we have? 4 of them. So we're going to write this as 2x minus 4. It's just describing what we have, but we've given these shapes a name. Okay? Second one. You see I have 3 white rectangles? The white ones are negatives, so we have minus 3 x's. And we have 6 shaded ones plus 6. So make sure you're writing this down in your notes as we're doing them so that you can see it later when you're studying. Third one here. What do we have? We have 2 big squares.
2.
Those are x squareds. The 3 empty rectangles, well, the empty is negative, and the rectangles were x's. And the little squares are numbers, we just have 1. For each of these, we're going to draw the Algetiles. We might actually draw it in algebra as well. I think drawing it in algebra might be easier as a starting point, and then draw the Algetiles after. So what does it mean to be 3 less than twice x? Twice x is 2 x's. 2 times x would be twice x. 3 less. You're going to add, subtract, multiply, or divide? Minus. So 3 less, you would minus 3. Can you draw the Algetiles? Shade for positive ones, don't shade for negative ones. Opposite. When we use the word opposite in math, we mean a negative. Okay, check your drawing. So hopefully, let me just double check. Did you draw before? No, some of you haven't. Okay, I gotta erase this. Your job was to draw it first. I don't see drawings on a lot of yours. The 2x minus 3. I want you to draw the Algetiles, shade what you want. Copying just notes down does nothing for your brain. doing it first on your own. So I want you to draw the Algetiels for that. Good. Because if you do it first on your own and then check, you will find out where you make your mistakes. Okay? That would be your 2x's. That would be your -3. They got to be little squares. Good, good, good. Okay, for B. Did you just draw the X tile with a negative? So we don't color it in. The sum of the opposite of X and 2. So I'm going to color code a couple things here for you guys. Keywords. I see sum. I see opposite of X. And I see 2. Okay. Opposite of X. That's what that would look like. Sum means plus. And 2. So the opposite of X and 2 are added together. So you see how I color-coded the words in the question? And then wrote those in algebra. I'll write the next one. 4 less. So I'm going to 4. I've got less than. And I've got x squared. Okay. The less than is subtracting. Will I do 4 subtract x squared? Or will I do x squared subtract 4?
That's true, subtract 4.
X squared subtract, because it's less than the x squared. So the x squared would be first. And then we would subtract 4. Okay, draw the Algetiels for these ones. And check, how did you do? Did you draw one rectangle empty and 2 squares filled in?
Yes.
Yes.
Excellent. X squared minus 4. Did you draw one big square empty? Nope. Filled in. Such pretty shading. And then minus 4. Draw 4 little squares.
Yeah. Una pregunta. ¿Esa caja tiene la forma de Windows?
Una forma del window?
Sí. No esa.
Esa,
Wow.
yeah, it looks like a little window.
Who's that creeping in the window? How come? Not move?
Now, I have a question for you from middle school. Did you ever in middle school use the 100 tile, the 10 tile, and the 1 tile for math? Yeah? So if you did that in middle school, all we're doing now is we're saying the same kind of ideas, but instead of 100 tile, you don't know how big it is. It could be a 25, it could be a 6, it could be an 8x8, it could be a 7x7. We don't know. So we have an x by x. But a lot of the math that you did with the 100, the 10, and the 1 tiles is very similar to this with the x squareds and the 1 tiles. Okay, I'm going to stop our video here.